Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Before we proceed to the part C, which is cool working and hot working, let me recap of the previous lecture, which is part A and part B. Okay, so for part A, we already covered of material deformation. In material deformation, actually this is new chapter for you. So in this part A, we try to make a deformation of metals. Okay, so the deformation of metal we can look from the ancient part, which is they use metal casting, whereby the molten metal they heat, and then the metal in form of a liquid metal, and then they try to make a mold, and finally they pour the molten metal on into the mold, and the desired shape that they are looking for will produce. Okay, so for the deformation, and then we look at the solidification. Okay, from the previous chapter we already learned about the process of the solidification, starting from nucleation, dendrite, primary and secondary dendritic. Okay, so in this process mainly we have a new type of deformation of metal. We have by using a machine related to the rolling process, forging process, extrusion, spinning. Okay, so that process include in room temperature, and also happen in higher temperature. Okay, let's say for the rolling process, maybe we can make a rolling machine from the metal sheet to make a different kind of shape. Let's say cylinder shape or something like that. Okay, but different can be done in room temperature or also in higher temperature. Okay, so after this we will go for the cool working and hot working. Okay, that machine can be done in cool working, especially done in room temperature. For the hot working, the deformation takes place in higher temperature. Okay, so and then we look at the main part during the deformation actually related to the behavior of metals in terms of in the microscopic point of view. We talk about the atomic arrangement of atom. Okay, at that part we can see during the deformation, let's say we give extra force and the deformation takes place, have look into elastic and plastic deformation. Okay, so and then we make analysis from the stress strain curve. From there we can see the area of elastic and also the area of plastic deformation. And at a certain limit, the elastic deformation will exceed and go for the plastic deformation. In this case, the plastic deformation, they call it a permanent deformation, whereby if you imagine of the rolling process, okay, let's say we have the metal sheet in the plain form, and finally when put in the machine, the rolling, and finally it will produce a metal bending, okay, in to produce a like kind of a cylinder or the circular shape of the sheet metal. So at that position we call it metal deformation. In this case the area happen, we call it in plastic deformation. Okay, when we talk about the plastic deformation, we will consider the happen in the okay, in the microscopic point of view, you can explain the deformation of the atomic arrangement, okay, and then it will produce a slip and twin deformation of atomic arrangement. Okay, and then in this part A, we also discuss on the dislocation motion. Okay, so during the process of the deformation, we have associated with the deformation movement or dislocation motion. So the dislocation motion actually we can manipulate by looking at the atomic arrangement, and finally we go for the part B, which is in the part B we discuss on the how to block the dislocation motion. Because of this dislocation motion actually can soften the material. Okay, so during the plastic deformation, we want to manipulate this area because of we want to suit the application of particular metal. So this metal suit for this application, this metal suit for the different application. So we need to study more on the fundamental in terms of atomic arrangement or associate with the deformation and dislocation motion. So when we study the dislocation motion, we need to stop this dislocation. Once we let the dislocation motion happen at the certain length, it will reduce the strength of the metal. So the metal we need to make it strengthen and also to make it extra ductility. Okay, so in order to manipulate this, we need to understand the suit for the application and also to understand the graph stress strain curve in order to make it the strength more higher. Okay, so in order to suit for this, we need to have extra strategy in strengthening mechanism. Okay, that we talk about in part B. Okay, in part B, the strengthen mechanism, we have four types. We call it mechanism. The first one is basically for the grain size reduction. The second one is solid solution hardening. Okay, in part B, we already covered grain size reduction and solid solution hardening. In part C, after this, we will cover the strain hardening and precipitation hardening. So in part B, we already covered grain size reduction. In grain size reduction, actually, we manipulate the grain size. Okay. So previously, we looked at the grain size effect. In order to obtain more strength material, the grain size supposed to be smaller. Okay, once it's small, the area of the grain size, whereby the grain boundary will block the dislocation motion. Once it will block the dislocation motion, it will not happen the dislocation through the grain boundary, and finally it will increase the strengthen of metal. Okay, so a lot of grain size can be controlled by using a solidification rate. We can make it faster solidification, or in plastic deformation we can manipulate. In plastic deformation also we can introduce heat. Okay, so we can introduce heat in order to manipulate the grain size. Okay, so and for the grain size reduction, basically it will look at the grain boundary angle between the orientation of each neighboring atomic arrangement. Okay, so that we will see it in the high angle and lower angle. So higher angle, it will block more than dislocation motion, so it will make difficult to dislocation motion to pass through, or if compared to the small angle. So and then we go for the solid solution hardening. In solid solution hardening, actually we put more foreign material in the metal solution, liquid metal. So in this solid solution, actually the the effect of the foreign metal, or we call it element, or we call it impurities we put inside. Okay, so the effect of the impurities, we will make the metal in different form. They call it alloy. Okay, so once we introduce the foreign material, now the material become the alloy, or we call it, if we use aluminium, we put several two or more foreign material, it will produce aluminium alloy. Okay, once we have the silver, we put copper in the small portion, they call it sterling silver or something like that. Okay, so if we have iron, we put more carbon at a certain amount, it will produce steel. Okay, in this case, we will learn more on the next chapter of the iron and then effect of carbon to produce a steel. Okay, so next chapter we will go for that. Okay, for the existing of the foreign material, it depends on the foreign material whether the atom is bigger than the initial metal or smaller than the initial metal. So that different size of the foreign material will affect the stress between the neighboring into the atomic bonding. Okay, stress. Okay, I don't want to explain more on that. Okay, later on you will already you have a video. So after this, you will see the video. Okay, so the last lecture I already finished edit the video, and after this I will give the link for you to watch the video. Okay, so for today, part C, we will go for the cool working and hot working. Okay, in this cool working and hot working, actually we will need to have several part of the understanding of the term that we use. Okay, so we already covered the grain size reduction and solid solution alloying. So basically, in the strengthen of metal mechanism, you can if asking for the list down the strengthened mechanism, you need to list down 4, which is include strain hardening and precipitation hardening. So if there is a list 2 and explain, you can list wherever you want that you can explain in this 4 mechanism. Okay, you can choose 2 out of 4. Okay. So for the strain, so we will go for the third one is a strain hardening. So in this keyword, we have strain hardening. Strain is related to the stress in the lattice structure of the atomic arrangement. So in this case, we will go for the term that we will use after this. Okay, so the first one is a ductility. Okay, the ductility is a measure of the metal ability to undergo significant plastic deformation. Okay, bahasa Melayunya disebut mulur. Okay, ductility can deform. Okay, under the if we introduce the force, and it will go for the significant plastic deformation before it rupture or breaking, which may be expressed as a percentage elongation or percent area reduction from the tensile test. Okay, so this is the ductility. Okay, as you can see from this diagram, we have the ductility versus the brittle. The ductility, the process of the plastic deformation get quite a bit longer if compared to brittle. Okay, brittle ni rapuh. Okay, brittle. Okay, for the ductility, the ability of material to have a shape change. Okay, okay, sebab dia dalam area of plastic deformation, it will change the form. And if we can see during the tensile test, the metal deformation happen at this point. We can have having a necking area here and finally break. Okay, so the deformation takes place around here. As you can see, the original size is diameter is bigger. At this point, the diameter is more smaller. Okay, if compared to the brittle, as you can see, the brittle at a certain point, the original shape, and then at a certain point, it will break. Okay, um, the diameter before and after can be slightly the same. Okay, the diameter. So for the ductility, as you can see, example of the ductility metals. Okay, most of the metal are good example as the ductile materials. Okay, whether the plastic deformation area bigger or smaller is depend on the we can manipulate by uh, applying these 4 metal strengthening. Okay, so and then we have brittle. Okay, as you can see, brittle is defined as something hard but prone to crack or breaking. Actually, if compared to metal, at the certain position of height, if we can see the strength between brittle and ductile, the brittle is actually very strong than the ductile material. So it very hard, but once we apply force, it easily break. Okay, okay. So this is the disadvantage of we having a hard material, a strong material, but the downside is very easy to break. Okay, at a certain cost. Okay, so when subject to stress, it will break. Okay, little elastic deformation and without significant plastic deformation. Okay, so the region whereby it exit of elastic, when the limit is exceed, it will break. Okay, brittle material absorb relatively little energy, okay, prior to fracture. Okay, the example of the material which is glass, ceramic, graphite. So that one is quite hard. When we give extra force, it will break. Okay, so that's one in the category of brittle. So for the hardness, okay, actually the hardness we already learned in the previous lecture, including the testing of hardness. Okay, this one is a material to resist deformation. Okay, we study the hardness by using the testing of material hardness, okay, which is determined by the standard test. Okay, during the test we have a Brinell hardness, we have the Kurz hardness or something like that. Okay, so we already learned about the hardness testing. Okay, by using the indentation. Okay, at the different size of the indentation material. Okay, and shape. Okay, for the detail of this application of the testing, I can refer to the previous lecture. Okay, and then the most common use hardness tests are defined as the shape of the indent, size, and amount of load applied. Okay, so this one we will give the information of the hardness of the material depend on the different method of testing. Okay, and then we have the annealing. The annealing is basically the heat treatment. We will introduce the heat at the different temperature, okay, whereby it will alter the physical and sometimes the chemical properties of the material. Okay, okay, at that position, the material will increase ductility and reduce its heat hardness, okay, making it more workable. That means during the process, if we have the material that is very hard, okay, hard to deform. Okay, at a certain temperature, we will need to make annealing process whereby we introduce at a certain temperature below the melting temperature to make it workable. So during the process macam kita buat forging of macam buat keris, buat pedang, buat pisau, apa semua tu okay. So depend on the material. If the material is physically hard, okay, we cannot forge it at by using a room temperature. We need to introduce heat at a certain temperature, and then it will allow us to make a deformation. That means kita boleh ketuk dia, boleh bagi change the shape workable punya making process. Okay. So at that condition, it will reduce the hardness. Okay, the hardness of the material, and it will increase the ductility. That means we can form it to the different shape. Okay. So, and in this, the change in the hardness and ductility is a result of the reduction of the dislocation. Okay, when we talk about the dislocation, we allow the dislocation process happen when we introduce the heating. So we allow this dislocation, and it will result the metal deform. Okay. So also call the strain hardening. The other word they will call it cool working, or other term they will call the work hardening. So basically, the term that we use, work hardening, cool working, the strain hardening, is the same term. Okay. Mainly when they use a cool working, they will associate with the hot working. Okay, because we can compare the cool working process and the hot working process, and then we can differentiate. We can see the difference between cool working and hot working. Okay. Okay. The cool working is the process making a metal harder and stronger through the plastic deformation. Okay. So this is the process. Mainly the deformation of the material occur at a temperature low enough, okay, if we compare to the melting temperature of the material. Okay, so the atom cannot rearrange themselves, okay, because of the bonding between atoms already established. Okay, so that in the cool working process, the process will take much harder if compared to the if we introduce the higher temperature. Okay, so let's say we have the metal at the room temperature, and then we want to bend. Okay, we need extra force to bend it if compared to metal at the higher temperature. Okay, easily to bend. Okay, like kita nak buat keris ke, we introduce a higher temperature, kita masuk dalam furnace, and we can see the keris at color of like orange color, higher temperature, and can easily to bend. Okay, if compared to the room temperature of keris, and then we want to bend it. Okay, maybe it need a lot of extra force, or finally it will break. Okay, something like that. So we will call it the temperature we introduce is basically below is recrystalline temperature. So after this, you will see the recrystalline term and definition. Okay. The most cases, okay, such cool forming is done at room temperature. Okay, when we talk about the cool working, most cases is happen during or the condition takes place in room temperature. Okay, dalam keadaan biasa. Okay, so that during the process of rolling process, the forming process, we will done in room temperature. Let's say we have the sheet metal and then we want to bend it to make it a cylinder or to make it a circular pattern of the sheet metal by using a roller machine. So we will do in the room temperature. So it will we can see the advantage and disadvantage of these things, okay, for the cool working, okay. So when the metal is worked at the higher temperature, okay, this one if we compare to the introduced higher temperature, metal we will show a different color, okay, orange color, okay, macam form of grease macam tu. When we work at the higher temperature, that one we will call it hot working process, okay. And then if the hot working process, the dislocation can be rearranged, okay, dislocation because of the plastic deformation can be altered and the little strengthen is achieved, okay, sini ya. Okay, when a metal is plastic deformation, okay, dislocation we will start to occur and the dislocation movement takes place. And we can see dislocation generated, okay, in the process. Okay, the more dislocation with material, the more we interact with the distance decrease. Okay, so when we introduce the metal forming, the dislocation takes place. In the cold working, also the dislocation takes place, and we can see it movement. And more dislocation will take place in the this process and will tangle between each dislocation, okay. But the dislocation as we can see, the movement is everywhere, okay, because of a lot of dislocation and will tangle or pin between them, okay. And finally it will make a dislocation block, okay. Banyak-banyak dislocation happen at the different angle, it will block each other, okay. So finally it will result the decreasing of the mobility of a dislocation, and finally it will block at the or pile up at the grain boundary, okay. And finally the metal strengthening can be produced, okay. So dislocation density increase, okay. In this case, a lot of dislocation takes place. Density is we call it the density of dislocation. When it increase, it will produce a resistance to the dislocation motion, and finally a greater stress required, okay, for the deformation, okay. And during the process we can see a lot of strain produced in the atomic arrangement, okay. When we talk about the atomic arrangement, after this we will see the strain in the lattice, okay, due to the dislocation motion takes place, okay. In the summary of this, if we have more dislocation motion, okay, the distance will decrease because the tangle or pin between the dislocation takes place, and finally it will pile up at the grain boundary, and as a result the dislocation will block, okay. As you can see, here is a diagram to illustrate the amount of the cold working process and what happened to the hardness, strength, ductility, and grain size, okay. So as you can see, this is the initial grain boundary. As you can see, the original structure. And once we introduce the cool working process, let's say we introduce a rolling process at the room temperature, and what will happen to the hardness, strength, ductility, and grain size, we can see like something like this, okay. For the effect of the cool working, okay, we can see the ductility is start to reduce, okay. So the original grain size is something like this, and it will deform finally something like this during the rolling process. and we can see the ductility will reduce. Okay, so mulu dia lebih lagi ya. Okay, and if we can see the hardness and strength, it will increase at a certain level. Okay, so if we look at the effect from when we do full working, hardness start to increase and strength start to increase, and the ductility will decrease. Okay, as you can see, a grain size a little bit change. If we can see the deformation of the grain size here from this size and then transform to the this size. Okay. Okay, if you look at the figure B here. Okay. So the grain boundary at B is disorder structure at high density dislocation. Okay, so we can see the dislocation will start to happen at a certain angle here, which are replaced by the original defragmented grain boundary here. Okay, original. So when we start to do cold working, the ductility will reduce, the hardness and strength start to increase. Okay. This one, we can see from the analogy of the like pin here. Once we bend the pin, and actually it will produce at this point. Okay, at this point is reduce the ductility, and at this point actually the harden and also the strength it will increase. Okay, once we introduce the point more deformation at this point, it will finally break this pin. Okay, so this is the analogy of this kind of thing during the cold working. Okay, bend a straight section back and forth several times, and finally it will break. Okay, okay, so major cold working operation can be classified basically as this one is in the manufacturing, in the production line related to the metal process. Okay, several type of process we can see squeezing, bending, shearing, and also drawing. So in this category also a lot of activity can be done in the squeezing. There is a activity process of rolling, swagging, cool forging, sizing, and other term of metal process. Okay, deformation process, extraction, debating, or something like that. So in this category of squeezing, there's a lot of process happen. Okay, and also bending, shearing, and drawing. Okay. So the three of the most common type of cold working, basically we can see for the hardening related to the cool rolling, bending, and drawing. So for the cool rolling is basically we use a machine whereby this one we call it a most common method of cold hardening, work hardening or cold working process. Okay, whereby we have the roller and then we put the metal between the roller, and then we start to make a roller process. And the initial grain boundary is something like this. And after the roller takes place, we can see a very small metal sheet produced, and it will show different at the final grain boundary will show is something like this. Okay. So this is the rolling process, the cool working at the room temperature. Okay, metal move to the roller and is compressed. The metal grains are deformed. Okay, and then example of cool rolling products include a steel sheet, strip, bar, and rod. Okay. So for the bending, what about the bending process? The bending is something like we deform at a certain position, whereby we introduce force at a certain work exists, and finally we will making a desired shape. In this case, we have the metal sheet, and then this force at a certain position, and finally it will produce a bending like a V shape or something like that. Okay. So example of this is in the steel or aluminium for car parts. Okay. So we want to produce a certain shape of the car part, like a bonnet, like a door of the car parts. Okay. And finally, we have a drawing process whereby we introduce the original shape is something like this. Okay, and finally we can see a different shape at a different diameter. Okay, this one related to the pulling of metal through a small hole or die. Okay, so in this case we have the steel bar and aluminium rod. Okay, from the higher or the bigger diameter, and finally we want to produce a different diameter. Okay, so we will introduce this kind of drawing process. Okay. So basically, it will happen in room temperature. So there is an advantage and disadvantage of this. Okay, actually, for the cool working advantage, we can see the advantage is improved mechanical properties. Okay, whereby hardness, tensile, and fatigue strength is more increased. So, and for the maintain high dimension accuracy, and how well the object match the size and the specification. So in this case, because of the rolling process, we already set the diameter that we want at the final product, okay, or the drawing process that we finally set for the final product. So the achievable of the metal deformation at the higher high-end product will meet the high dimensional of accuracy. Okay, so previously we set what kind of dimension that we want to final product. The final product actually produce the same higher dimension, okay, quite high dimensional that we obtain from the final product. Okay, it prevent loss of metal due to oxidation. So in this case, during the process of the cool working, it will prevent from the oxide layer produced. Okay, so when we want to use like aluminium at the room temperature, okay, during the process of rolling or flowing takes place, the reaction between the temperature is reduced, so that the prevent of the oxidation. Okay, so if compared to the hot working, after this the hot working we will produce more on oxidation because of related to the higher temperature. So the when it's high temperature, it will easily to in chemical reaction between oxygen, and it will produce a oxidation layer on top of the material. Okay, so have a better surface finish. Okay, during the process of rolling, so the surface of rolling we already said that the surface area is very high using a machining at the roller. So during the process of roller, the surface finish is very good. Okay, in terms of the surface texture, in terms of the topology, and also the roughness. Okay, so finally the process of this kind of thing will produce a higher quality of material. So this is the good thing, the advantage of the cool working. For the disadvantage of cool working, we can see that the decreased ductility. Okay, during the process of cool working, the ductility is decreased. Okay, and then higher force required for deformation. Okay, actually when we use machine, we we cannot notice of the force introduced, but during the process maybe we can imagine of the we want to bend the like sheet metal by our hand using a manual. So that one we need to knock it very high in order to make it bend. Okay, so in this case, for the full working, we need extra higher force in order to make it deform. Okay. So may produce undesirable residual stress. Okay, produce distortion in grain structure. Basically, when we introduce the cold working, okay, the deformation of material, if we look in terms of grain boundary, it will change the deformation. Okay, it will change from the initial to the final deformation of the grain boundary. In this case, a lot of strain happening in this grain structure actually. Okay, so it will produce a distort in grain structure. Okay, when it will produce a distort in grain structure, it will attention of to produce a cracking of the metals. Okay, so during the process, we don't want to have the product by produced in cold working to have a cracking. So actually during the process, tendency to crack can be happen. So that's why the advantage of this will produce a distortion in grain structure, and finally it will produce a crack of the metal. Okay. So produce internal stress in metal proper heat treatment. So when it will produce the stress in the lattice structure of the atomic arrangement or stress or distortion, so we need to have an extra process to reduce the stress. Okay, so in this thing, during the cool working, we need to have an extra process to reduce the stress by introducing the heat treatment after this. Okay, so during the process, we need to have several steps during for the heat treatment. After this, we will see to introduce the heat treatment so that we will reduce the stress. Okay, and finally, we will prevent for the metal to crack. Okay, so what will happen in terms of the atomic arrangement related to the stress? Okay, so during the cool working, we can see a stress at this area taking place, whereby other word, they can also explain the strain lattice in this area, whereby we can see the atomic arrangement at the upper and the lower is quite the initial position. Okay, the bonding is between this area is in the original position, but in this case, when we introduce the cold working, the stress, actually the lattice strain happen in this area. So you can see there is a atomic arrangement a little bit misaligned here. So that one related to the strain energy form. Okay, so when the energy formation here, so we produce the internal stress and lattice strain. Okay, so can lead to cracking. I already explained to you. So in order to avoid from the cracking, we need to introduce the heat treatment. Okay, the heat treatment is basically we introduce the heat, or we call it by using the annealing process. Okay, whereby we introduce the heat. Okay, it will relieve the internal stress or lattice strain. Okay, so the annealing process is kind of process of the metal is heated, whereby the temperature is whereby below the melting temperature of that material. Okay, so that in order to metal to release the stress, okay, at this region. Okay, and then the stored energy will reduce, and finally it will come back to the strain-free condition. Okay, so the condition is something like this, that the upper region, no strain lattice here, So we call it the strain-free condition. So during the process, the cold working, basically, if we talk about the macroscopic point of view, we have atomic arrangement, lattice energy produced, whereby the internal stress energy taking place and it will lead for the cracking. Okay, and then we will go for the annealing. Okay, for the annealing process whereby we introduce the heat to above the recrystallization temperature, whereby below the melting temperature. If we have a certain material or metal at molten temperature or the melting temperature at a certain number, so during the process of annealing, we want to introduce. Okay, the process is basically to improve the cool working properties. Just now you can see during the cool working, the hardness, the strength of the material increase, but the ductility is decreased. So we want to increase ductility process, ductility, and to retain of the hardness. Okay, the hardness we want to make it. We try to keep the hardness. Okay, we want to increase the ductility because during the cool working, the ductility decrease. So we introduce annealing to make it the ductility increase. Okay. So there are 3 steps involving annealing. Okay, during the process, okay, we need to introduce recovery. Okay, the process is 3 steps happen. Okay, recovery whereby the process is removing internal stress in metal because of the when we introduce the cool working, internal stress happen yang tadi yang kita tengok tadi. Okay, lattice strain introduce. Okay, we have the store energy apa semua and then lead to cracking. So during this process recovery, we want to remove this kind of thing. Okay, so internal stress nak remove. Okay, and heating it below the melting temperature. Okay, so we will introduce at a certain level of temperature below is melting temperature. That one is the recovery. The point for the recovery is to reduce or remove the internal stress. Okay, kalau tak dia crack. Okay, and then the process next is the recrystallization. Okay, the process of the crystallization is the new set of strain-free grain in metal produced. Okay, recrystallization is proses. Kita tahu sebelum ni crystallization ataupun other term they call it solidification, involving nucleation, dendrite, premier, secondary, dendritic apa semua tu. Okay, in this case, at a certain below than we heat metal at a below temperature of the melting point. During the process, it will produce a new set during the recrystallization. Okay, new set of the grain boundary. Okay, or nucleation will take place. Okay, yang sebab tu dia sebut sebagai recrystal. Okay, so the point dekat sini kita nak introduce nucleation again. Okay, from the original grain boundary. In the grain boundary, there is a nucleation takes place. After this, we will see. Okay, and then the final part is a grain growth when the recrystal or nucleation takes place, and then the crystal will make it bigger and bigger, and then it will start to form a dendrite, the grain and bigger size of grain. Okay, so the original grain size in the during the process of the cool working will removed by the new set of the nucleation. Okay, the recrystallization. Okay, study we'll see. So we have the recrystallization temperature is basically when we compare to the melting temperature of material. Let's say we look at the aluminium. So aluminium melting point of aluminium is 660.3. Okay, so when we introduce a temperature at the recrystal temperature, the temperature is around 150, can be a recrystal again. Okay, so basically the recrystalline temperature is below than melting temperature at, you can see various different material, okay, at the lower from the melting temperature. Okay, so as you can see, there is a diagram here. So this diagram show that the process of the previous diagram you already see here, this part. Okay, this part we call it cold working process. Okay, during the cold working process, as you can see, the ductility start to decrease. Okay, we don't want to, kita dah deform material daripada bigger size. Katakan kita guna kaedah drawing yang tadi tu. Okay, we have a bigger size diameter of rod, and then we want to produce the final smaller diameter size. During the process of drawing process, original dia ductility very high. During the process, that final product, the ductility is very low. So we don't want to have the ductility is very low. So we want to increase the ductility. Okay. So, but the hardening, the stenting is increased. But during the process, okay, the deformation takes place whereby the grains boundary is something like this. So this delocation process, in terms of the atomic arrangement, it will produce strain, lattice, and it will this area we will crack. Okay, so in order to avoid the cracking, we want to release the internal stress by introducing of the annealing process. In the annealing process, there is three part here. Sorry, three part. The first part here is recovery. Ni yang kat sini. Recovery. So we will increase the temperature, as you can see here. We will increase the temperature. And when we increase the temperature, three happen: recovery, recrystal, grain growth. So during the process, we will see different shape of the grain boundary taking place here. So, and then we will see one by one. Okay. So this is the macroscopic point image. As you can see, this is the real image of the, by using scanning electron microscope. This is the original cold working of the metal, but this metal is ductility is low. So they want to increase the ductility. During the process, they increase the temperature below the melting temperature, and then it will start to initiate the recovery process, and then the process of recrystal takes place. We can see nucleation will takes place and start to grow, and finally at the higher temperature we can see a different kind of grain boundary. Okay, so in this case, we produce again they call it recrystal. They produce again grain boundary, grain size or different with a different size as other after we introduce the cold working. Okay. We will go one by one for the recovery. Actually, the recovery is happen in this area whereby when we start to increase the temperature, as you can see in the recovery process, the strength, the hardness is significantly the same. Okay, at the straight line here, and nothing changed during the process, but the ductility is start to increase. Okay. Okay. The recovery is process removing internal stress. Okay. So as you can see, the initial of the cold working is something like this. consists of the internal stress, the energy storage here, and it will produce a cracking. So we want to reduce it by introducing a recovery at a certain temperature below the melting temperature here, and it will remove the stress. Once it remove the stress, the ductility will start to increase. Okay. Okay, in terms of the dislocation density start to reduce and rearrange themselves, and it will block, and finally the internal stress reduce. Okay, so a little bit increase of ductility. Okay, and then when we talk about the at a certain temperature, recrystallization takes place. We can see the grain boundary is something like this if compared to previous. As you can see, small grain boundaries taking place in the initial grain boundary here. Okay, at this time you can see there is a significant drop of the hardness and strength. Okay, and for the ductility, it start to increase. And this time we call it a new strain-free grain nucleation takes place. Okay, and equates process grain taking place, the old deform grain dislocation at the grain boundary. Okay, so new set of grain whereby the new set is free from strain in the existing of the strain punya old grain boundary. Okay, so in this case, new grain grows, eliminate the deformed grain. Okay, so at a certain temperature, finally we'll go for the grain grows. Okay, and we will have this kind of okay, for the recrystallization process, new grain form as very small nucleation and replace the parent material. Involve a short range diffusion. Dekat sini proses dia when we talk about the atomic arrangement related to the nucleation, you already learned about this one from the previous solidification, which is nucleation. We have primary grain growth, we have secondary grain growth. Okay, then something like this, the process, the initial one is something like this. During the process of the recovery, okay, once the recrystallization takes place, we can see a small nucleation takes place here. Okay, small grain boundary, and bigger and bigger nucleation takes place. And as you can see, until a certain level, the white dot color is start to make it bigger, whereby the nucleation grow in the strain-free grains, and finally it make it bigger, and it will eliminate the whole grain boundary. Okay, as you can see here, and finally it will produce something like this. So the grain bigger at the expand of the old grain. Okay, grain becomes softer, weaker, and ductile. Okay, so in this case you can see new grain boundary produce. As we can see here from the graph, there is a slightly reduce of strength and hardness, and also increase of the ductile. For the grain growth happen in this area. Okay, we can see the in this part we have the after recrystallization, the strain-free grain will continue to grow, and finally we have the set of the new grain free taking place. Okay, whereby we can see the, if we look at the grain size is much bigger than before. So in this case, we have the grain increase in size, the boundary area decrease, and then the as thus for the total energy. Okay, whereby the grain, larger grain will reduce the strength and toughness, and it will increase the ductility. So if you talk about this from the grain growth, if you look at the microscopic point of view, actually the grain process, grain boundary taking place is whereby the grain boundary expenses are related to the diffusion that we learned from the previous chapter, the diffusion taking place whereby the grain start to increase. The increasing of the grains according to the grains boundary here, okay, happen during the diffusion process, okay. And we can see some of the grain boundaries start to shrink and some of the grain boundaries start to make it bigger, okay. So as you can see here, it related to the movement of the grain boundary. As you can see, the grain boundary move to this area become smaller due to the grain boundary shift to this side, okay, whereby the atom diffuse to the another side, okay. As you can see, the migration of diffusion of the atom to this side, and it will shift the grain boundary, okay. So this is the mechanism of the diffusion taking place, whereby the grain boundary start to make it bigger and some of the neighboring grain boundary start to shrink and disappear, okay. As you can see here, this grain boundary start to make it bigger in size, and below grain boundary start to shrink, okay. So this is the you can see the simulation taking place of the grain boundary between neighboring, whereby some of the grain boundary size become bigger and some of the neighboring become smaller, okay, during the process. Okay, and then finally we have the precipitation, the number 4 of the mechanism of the how to make it strengthen of metal. The final part, we have the precipitation hardening. So the precipitation hardening related to the material to the growth of the precipitate that impedes dislocation motion. Okay. There is a heat treatment technique, okay, used to increase the yield strength of malleable material. Malleable material ni kalau bahasa Melayunya boleh bentuk lah. Okay, we call it the properties of metal that describe its ability to bend. Okay, hammered or into a thin sheet without breaking. Okay, so this is the malleable. Okay, so the this one is related to the alloy metal sheet or something like that. Okay, generally there are 3 steps that are involved in the precipitation hardening process. Okay, so the first one is solid treatment, solution treatment. The second one is quenching, and the third one they call it edging. This one is the same in the one graph, as you can see here. So in this case of the precipitation hardening, the process is something like this. The first one is when we increase temperature at a certain level, the material will start to heat, and at a certain level, the process we call it the solution treatment. As you can see in the grain boundary size is something like this. Then we start to do a process we call it quenching. Okay. So after this, we'll see one by one the process. The quenching process whereby we introduce a very fast cooling process. Okay, at this one, at a certain point, we have around 600 degrees Celsius. the quenching at a small amount of time, the temperature will reduce very fast. As you can see, grain boundary is different, and then it will start to do heating at a certain temperature. That one we call it aging process. Okay, and then start to cooling again, and finally we will see a different kind of the grain boundary happen. Okay, we compare here grain boundary and this grain boundary. Okay, so the process, three-step in precipitation process, we will see one by one. The solution treatment is basically related to the heating at the higher temperature. And then basically process involve the heating of the mixture. Okay, this one we will add something and then to a high temperature. Okay, and then we will produce a uniform dispersed particle. That one actually we can see small particle dispersed uniformly in the grain structure that will this particle actually to block the dislocation motion. And then the process of quenching, okay, whereby this process it will cool down very quickly at a certain time, okay, by soaking in metal. This one quenching related to different technique. Some of the quenching they dip in the water, okay, very fast. Macam kita pernah tengok kalau buat keris ke, buat pedang ke, and they heat at certain temperature and then they make it bending, and then finally they will dip in the water. That one, this is the process, okay, to make it stronger, okay. So the quenching, they will dip in the water or some of the solution like oil or something, okay, to cool it down very quickly. So the cool material we quickly quenching to lock in the complete mixed state, okay, at a certain grain boundary, okay, so that it will dip in the water or dip in the oil, the grain boundary we will lock, okay, the position, okay, so that it will make metal harden. For the aging, they will increase the temperature at a medium temperature, and then they will give a temperature at some time. Okay, they put this temperature at some time. So and then they start to reduce the temperature, okay, to make it cool. Okay, that one is give one is the aging process is to give a high enough diffusion of the metal so that it will lock, okay, the atomic will lock at that certain position, okay, and finally it will cool again at room temperature, and we will final product will obtain, okay. Okay, as a result, harder, stronger material can be produced. Okay, this is the process of the summary of the precipitation hardening. Okay, we will introduce the high temperature and then start to quenching very quickly, and then heat at the medium temperature, and finally cool at the room temperature. Okay, and finally for the we already learned of the cool working, and then we need to look at the hot working. Okay, hot working is we can differentiate between cool working. The hot working is basically we introduce high temperature, okay, above the recrystalline temperature, whereby we will make a deformation, or we will change the shape of the material under the force, okay, or pressure. Okay, this one example of the process we can see from the carbon steel. okay, whereby we have the temperature greater than 1000 degrees Celsius, okay, that one related, this hot working actually will be done when we deal with the material that the melting temperature is quite high. Okay, so that we have to use extra or harder force, okay, extra force that required to use, okay, if compared to the cold working. So once we related to cost or something to bend the material, so better we will use a hot working process. Okay, so during the hot working process, the force not lot force will be used, okay, if compared to cold working. Okay, distort of grain structure and grain hardening produced by deformation are rapidly eliminated. Okay, so during the process, the strain hardening of the metal or the distortion of structure, okay, so we will eliminate. So that one very easy to form. Okay, so that a new strain free grain will produce, and the advantage of the hot working, actually the hot working is a easy work, okay, rapid and less energy cost for deformation. Okay, so we already introduce the temperature, so the stress strain free of the lattice structure not happen, so it will really easy to bend it, okay, by using a small amount of force. Okay, and then improve mechanical properties. In this case, recrystallization takes place and it will increase the toughness, strength, and ductility. Okay, and also for the eliminate blow holes and less porosity. Okay, during the process of the solidification, a lot of defect taking place. So for the hot working, it will eliminate this one. Okay, and then for the no internal or residual stress produced. Okay, of course. And then for the formation of refined grain structure, we will produce. Okay, so for the disadvantage, okay, material lost to oxidation, okay, during the process at a certain temperature, it will make chemical reaction between the oxygen of the metal taking place, and it will produce the oxide. Okay, let's say we have the aluminium combined with oxygen will produce the aluminium oxide. Okay, so the copper will produce a copper oxide, and also we have the iron oxide or something like that. So during the higher energy or higher temperature, the reaction between in the chemical reaction will easily taking place. It will oxidation of the surface area will happen and will reduce the amount of material. Okay, so we don't want to have this kind of thing. And then the poor surface finish during the process, okay, if compared to the cool working. So, and then for the dimensional tolerance and greater than cool working. So this one is a tolerance, and also for the structure and properties are not uniform over the whole cross section. Okay, so we cannot get what we want, okay, during the process. Okay, and then higher cost of tools. So we need to have the process of the related to material that can tahan pada temperature. Okay, so we deal with the higher temperature. The parts that we machine that we use need to withstand from the higher temperature. So a lot of material involved during the process to produce a machine that can withstand from the higher temperature. So high cost will tool is involved. Okay, for the hot working process, some of the hot rolling, also cooling, cool working also related to the hot rolling also. Okay, cool working. So hot rolling, forging, also hot spinning. Okay, this one related to the hot working process. Hot extraction. Okay, hot drawing also. So and hot piercing. So a lot of machine related to this hot working, and also some of the process, rolling process, drawing process also can have a cool working process also. Okay, so at for the hot rolling, something like this. So I think I don't want to highlight about the rolling process, but different is by using the high temperature. Okay, but the different is that one they use maybe related to the metal that high melting temperature. Okay, for the hot forging, and finally we have the extraction. Okay, for the head extraction. Okay, the end of this slide. So okay, thank you very much.